Hi guys, I hope you're okay, and I hope that the videos are helping you out. On this video, guys, I'll be doing question number 8. Né? Please do expect a total number of 40 questions. Euclidean geometry, guys, is a huge chapter, and it's very important to know how to tackle the questions in Euclidean geometry. All these questions, by the way, are extracted from past exam question papers. So please, guys, pay attention. We are told that in the diagram below, O is the center of the circle, radii OH and OJ are drawn. The first thing they told me is that O is the center, and I do not see any line from the center going to the chord. Are you together? So which simply means I'll only focus on the angle that says the angle at center is twice the one circumference. Immediately when I see this, only two theorems should cross my mind. Né? But for now, we'll only focus on the one that says the angle at center is twice the one at the circumference. So if angle O2 is equals to x, that means angle G will be equals to x. And then we are told that A is a tangent. A tangent, oh, excuse me. A tangent is drawn from K to touch the circle at H. Okay, a tangent is drawn from K to touch the circle at H, and then triangle HGJ is drawn such that GJ is parallel to KH. Okay, and then we are told that O1 is equal to 2x. We have a tangent, guys. Now we have a tangent, and we have spoken about the tangent in the center. That means we must definitely look for the relationship between a tangent and the radius, or tangent and the diameter. I know that tangent and diameter or tangent and radius are always perpendicular to one another. So which simply means the angle over there has to be 90 degrees. The H1 plus H2 must be always equal to 90 degrees, right? Okay, what else do I know? Since H1 is a tangent, that means these two angles are equal. Tan-Cot theorem. Are you together, guys? But remember that we're told that this line is parallel to that line. Né? That means we must have alternating angles. So which simply means that if angle G is equal to x, that means we also have an x there. Since H1 is also equal to x, that angle is equal to x as well. Now let's answer the questions. We have two questions, by the way. Name giving reasons 3 angles each equals to x. 3 angles each equals to x. We've already written them, né? But I want to show you how to write your answer with reasons. Firstly, angle G. Okay, let me write like this. Angle O1 is 2 times angle G. The reason behind this, angle at the center is 2 times the angle at the circumference. Are you together? So if that's equals to 2x, that's 2g. Therefore, angle G will be equals to x. That's the first angle, né? Angle G will be equals to x. Okay, since we are told that the lines are parallel over there, we can therefore conclude that angle H1 is equal to angle G. That means H1 is also equal to x. Why is angle H1 equal to G? Because we have alternating angles. And these angles are alternating because line JG is parallel to line KH. Are you together? So we have another X over there. However, angle GJH is equal to angle H1. So that means it is also equal to X. Why are these two angles equal? They are equal because of a tan chord theorem. Remember that, guys, tan chord simply says that the angle between the tangent and the chord is equal to the angle subtended by the same chord at the circumference. That chord HJ or JH subtends this angle at the circumference. Are you together? That's why angle GJH will be equals to angle H1 because of the tan chord theorem. Are you together? So the three angles which are equals to X, we have found them, ne? We have found the angles which are equals to X. The third one is this one. So we have found the angles which are equals to X. Now we are supposed to prove that angle H2 and H3 are equal. How can we show that? Let me erase. I hope you are subscribing in the meantime, lab. Angle H2 and H3 are supplementary. Okay, how can we show that these two angles, not supplementary rather, but they are equal, ne? How can you show that? I know that angle H1 plus angle H2 should give me 90 degrees. Why? Firstly, because OH is perpendicular to the tangent KH, ne? And hence we have a tan radius. Are you together? And hence we have a tan radius, ne? That means angle H2 is equals to 90 degrees minus X. Are you together? So this angle over here, let me write in green. That's basically 90 minus X. 90 degrees minus X. Okay. And how can we show that H3 is also 90 degrees minus X? Remember that, guys, we have a triangle over there. We have a triangle over there, and it's an isosceles triangle because OJ and OH are equal. Okay, you can simply direct the person who will be marking you that you are focusing on triangle OHJ, ne? This red triangle over there, and you can conclude that OJ, is equal to OH radii. Are you together? So which simply means that angle J1 is equals to angle H3. Are you together? You can simply say that it's true because equal sides subtend equal angles, or you can say that these are base angles of an isosceles triangle, or if you are lazy, you can just say OJ is equals to OH. Okay, and then I know that angle O1 plus angle H3 plus angle J1, they add up to 180 degrees. These are angles of triangle OHJ, ne? Sum of the triangles of OHJ. Angle O1 is 2x. Angle O1 is 2x. Remember that, guys, angle H3 and angle J1 are the same, ne? So I'll simply write H3 as well, plus, whenever I come across J1, I must just substitute H3, because they are equal. Therefore 2h3 is equal to 180 minus 2x, then angle h3 is 90 degrees minus x. So now we have proven that this angle over there is also equal to 90 degrees minus x. 90 degrees minus x. So we can therefore conclude that the two angles are equal because they are both equal to 90 minus x. Ne? They are both equal to 90 degrees minus x. That's how, guys, you're supposed to write excuse me, your answer. Okay, now let's go to 8.2. In the diagram, KLMN is a cyclic quadrilateral. Once they tell you, guys, you're dealing with a cyclic quad, please note that you must think of opposite angles which are supplementary. You must think of angles in the same segment. Think of exterior angle which is equal to the interior opposite. Ne? They told us K, where's K? It's KLMN. Okay, this is a cyclic quad over here. We also have another cyclic quad, guys. Before we even read further, this over here is a cyclic quad. Because the circle touches all the four-sided, touches all the four vertices of a four-sided figure. Another cyclic quad is this one. We have three cyclic quads over here. SS. And this one, the green one, has the exterior angle. Okay. Name giving reasons another angle which are equal to y. Now this thing is too dirty right now. Name giving reasons another angle equal to y. Where is y? Okay, there is y over there. Okay, remember that, guys, the first statement they told us that this is a cyclic quad. Let me indicate using a highlighter. This is a cyclic quad over there. This one. Are you together? So since this is a cyclic quad, I can therefore conclude that this angle over here is equal to that angle over there. Why am I saying that? Because they are subtended by the same chord at the circumference. So they're just in the same segment. So angle N2 is the one which is equal to y. Are you together? You can simply say these are angles in the same segment. In the same segment. Ne? These are angles in the same segment. 8.2.2, we must calculate giving reasons the size of angle y. We must calculate giving reasons the size of angle y. Okay, let me erase over here so that I can see what you are doing. We must calculate giving reasons the size of angle y. Remember that, guys, we just said this angle is equal to y as well. Yeah? So if we focus, guys, on the same cyclic quad, I know that the sum of the opposite angles should always be equal to 180. It simply means that angle 87 degrees plus 3y must be equal to 180 degrees. This angle over here is 3y because we'll say 2y plus y, you'll simply get 3y. Ne? And then 3y will be 180 minus 87. 180 minus 87, you'll simply get 293. Divide both sides by 3. Then y will be equal to 31. Yes, y will be equal to 31 degrees. The reason behind there, you'll simply say opposite angles of cyclic its opposite angles of cyclic quad K, L, M, and N. Please do specify, guys, which cyclic quad you are talking about, because earlier on we showed that you are dealing with 3 cyclic quads. Do specify that we are dealing with cyclic quad K, L, M, N. Okay, then now they want us to find the size of angle TPL. Let me erase there so that you can see this thing properly. Okay, they want us to find the size of angle TPL. This is the size of angle TPL, and that angle over there is an exterior angle of this cyclic quad. Are we together? Is an exterior angle of that cyclic quad, and obviously it is equal to angle K1, but K1 is 2 times Y, because these two are in the same segment, right? So which simply means that also angle, okay, let me say angle TPL is equal to angle K1. This is an exterior angle of cyclic quad PMKL, or PMKL. Are you together? However, I also know that angle K1 is equal to angle N1, which is equal to 2y. These are angles in the same segment. Are you together? So which simply means that angle TPL is also equals to 2y. Why? Because both angles are equals to angle N1. But we just found the size of angle Y. That's 31 degrees. So it simply means this angle over there is 62 degrees. This is 62 degrees. That's how, guys, we're supposed to tackle this question over here. What question was it? Question 8. Yeah. Just stay tuned, guys. More videos are obviously coming after this one. Thank you for your time.